What's up, Professor Wergeles here. We just got done implementing the start method, implementing the end method, the get name, and also we're working on update. Now, every time we open the program, we have to open up a file. So we hard-coded this file to make debugging a little bit easier for us. It opens up a default audio file and then go ahead and set up the user interface. So coming back to the visualizer, let's finish the update method. We've brought two of the algorithms over that we did in the audio visual lecture. So we talked about implementing those algorithms in the audio visual lecture and then bringing them over into the audio viz challenge. So if I come back over, you'll see we set X and Y. We set the center Y, so we moved the object up and down. We were also rotating images on the display, and then we changed the color. So here was the algorithm for the color for the ellipses. So I'm going to bring my color algorithm over, and I can copy one of these lines to make it a little bit easier. So if I come back to the visualizer, we'll go ahead and integrate this with our array. So instead of ellipse 1, it's going to be ellipses I, because I'm going to loop through the entire array. I'm going to do a set fill, and it's going to be based off magnitudes I. So I'm going to change 0 to I. I'm still going to multiply it by -6, and then the brightness, saturation, and the opacity will be set to 1. Now, I've seen students who are doing the outer space with the planets and stars. They would actually change the opacity based off of some of the values given. So they define their own algorithm, and they would set the opacity for the stars and make them brighter, and change colors as well, and then rotate the planets around the sun. So I added the fill, so I'm doing one at a time. So I'm going to go ahead and run this. And essentially for your program, if you use magnitudes, the algorithms for your program will be in this for loop. So you'll see once I run the program now, it will default to the song that we specified, and now I can click play directly. So I don't have to find the audio file, which speeds up the development. Here's the default visualizers. And here's the visualizer that we built in the audio visual lecture. So this was my algorithm. I moved the ellipses up, and I increased the radius of the ellipse. So the circle becomes larger. Now you'll notice the high frequencies aren't being activated much for my algorithm. There's not much movement over here. So we could talk about how we can fix that. But you'll see the color scheme works out pretty nicely. So I have greens and blues, then purples and pinks, and then red. So you can see when it's being activated, it increases in height, it increases in diameter, and then it also becomes a different color, closer to green. Okay, green and yellow, and then it'll go back to red based off the hue value given. So when you're running your program, make sure you test all this functionality. Does the slider work? Can I switch the number of bands? Can I change the visualizer without it crashing? Change back, come back to my visualizer. So far, this program's working successfully. Okay, adding on to the algorithm, there's still more to do. We can change the color of the background of the visualizer as well. So outside of the for loop, we don't need the for loop anymore. This will basically be to update the ellipses. I can use magnitudes or phases to then update the background color. So the algorithm that I came up with was I took magnitudes and I added that to 60. Now remember, magnitudes is from 0 to -60, and the lower bands are activated more because they're lower frequencies, and the really high frequencies on the song are very rarely activated because it becomes so large in value that it is almost impossible for a human to hear anyway. So we're going to use magnitude 0 in this case, and then magnitudes will be from 0 to -60, so this will be either 60 or it will be 0. Now I'm going to divide that by 60, so it's going to be 1 or less than 1. So it's going to be in between 0 and 1. I'm going to multiply that by 360, and I'm going to specify that inside my hue value. Now, if you're curious about these other parameters, you can open up the HSB function. So if I do a right click and do show Java doc, we can see that's hue, saturation, and brightness. So here's my hue value, here's saturation, and here's brightness. So I open this up, you'll see saturation is from 0 to 1, and brightness is from 0 to 1. So you can update these values and see what it does. So if I do 20%, run the program, click play, go to my visualizer, you'll see what it looks like at 20%. So let's say I change it to 90%. Let's say I change it to 90% and run the program. Click run, go to my visualizer, and you'll see how the saturation really affects how that color is being viewed. So on my circles, the saturation is extremely high, but that almost hurts the eyes a little bit. It's a little bit too bright. So if I go back down to 20%, in my opinion, that's a good percentage for the background color, especially since the ellipses have a saturation of 100%. So if I play this again with 20%, in my opinion, that's a good contrast based off of the given values of the ellipses. Now, essentially, that's it. So we pretty much went through the whole challenge. Okay, we created our own class. We started from the beginning. We implemented the visualizer interface. We talked about some variables that most likely you will also need. And then I created all my own custom variables. And then I told you how to do the start method, how to grab the initial style, make sure you called the end method at the beginning. We went over how to set the clip, even though that's not necessary. In some cases, like you'll see in Visualizer 1, it'll never go outside of the bounds. So I don't specify a clip here. I keep it simple. But for my visualizer, it could go out of bounds. So I do specify a clip, and then I went and told you how to add them to the display, how we divided by 2 and incremented by I. And then the end method is for taking all the objects off the display and returning it to its original style. Get name will return the human readable name for your visualizer. And the update method is where all your algorithms are going to go. So most likely you're going to have a bunch of objects on the display, so you can have a for loop to update them. The student who had stars, the first implementation, he only had 5 or 6 stars that were hard-coded, and then he decided to have it where it randomly generated stars. So then he implemented the for loop and then updated the stars accordingly. Now for his program, he didn't set them all in a straight line. He actually randomized where he would put them. So he randomized the X and Y coordinates, made sure that they weren't on the corresponding planet, and then he would take the magnitudes and increase the stars based off of the given band levels. Now, you'll see in my visualizer, one side's being activated a lot and the other is not. I'm going to show you one possibility how to fix that, so we'll see it in the next video.